All right, welcome everyone. Thank you so much for joining today. I'll give folks a few more minutes to jump in, and then we'll do a quick intro before we get started with the CEU portion of today's event. All right, looks like we've got a good amount of folks joining, so we'll go ahead and get started. My name is Bo. I'm here with Acelab. We are helping out with hosting today's CEU-approved event, Rainscreen Systems and the Building Code. It's presented today by Brock Osborne with StoVentec. Very excited for today's session. Before we get started with the AIA-approved portion, we are going to do a quick intro, tell you a little bit about Acelab and how you can use it to do product research and improve your projects, as well as tell you a little bit about what to expect after today's webinar, and how to get in touch with today's presenters if you've got any follow-up questions. So I'll go ahead and hand it over to my colleague Helen, our Director of Architect Experience, give you guys a quick intro about Acelab, and then we'll proceed with the CEU portion.
Thank you, Bo. Hey everyone, I'm Helen, and I will talk to you a little bit about what to expect as a follow-up for this webinar, and then also give y'all a little sneak peek of something we have coming out soon. All right, so from the homepage, if you want to get in touch with Brock down the line, or save some of their products to your projects and create some great comparisons, you can always, clear that up, type in the name of the brand that you're looking for. We're going to go to brands now instead of categories, and here we'll see Sto. You can jump in here to their page. Here you're going to see some information about where they're located, where they ship to, typical project sectors as well. You hit this contact button, that will start a conversation with Brock. What a conversation looks like in Acelab is once you hit that contact, you'll have a series of questions, what you're looking for, pricing information, lead times, things like that. That will then start the conversation up here. So you can always log back into your Acelab account, go into Workspace, hit Conversations. You probably won't have 238. That's just special for some of us here internally. It won't be as overwhelming as that. But maybe it would be if you have a lot of different projects you're working on. But what that'll do is then Brock gets a message and he will respond and pass it off to the appropriate team member as well. So we'll make sure you get the support that you need. At the end of today's webinar, you're going to have a poll. In that poll, you can also put what you're looking for. Myself or my teammate Evelyn will be creating either the project for you or creating that conversation and general research for you about what you're looking for. So if you're looking for product information, general research, you'll see that kind of come into your general research project that's already there for you in your Acelab account. One thing to note there, we really encourage y'all to respond back. There's two ways to do that. Log back into Acelab, hit Workspace, hit Conversations, and you can respond back to Brock, and then our teammate that kicks off the conversation for you. Or you can also just respond from your email. So whenever you have that conversation started or Brock responds to you, you don't even have to leave your inbox. You can just reply right there. And I mention this because what's really helpful is if y'all as architects can come in and let Brock know like your typical project types, your typical project locations. All of that helps ensure that he can get you the right literature and kind of the right person as well to connect you with on your projects. And even if you don't have a project, kind of down the line, again, he can tailor that literature to make sure if you're in high humid versus, Arctic blast kind of weather, you have the right resources you need. All that being said too, one of my favorite things to talk about here at Acelab is what we have coming out. So if I scroll on down, I'm going to be able to see video. I also will see some of Sto's products here. So I'm actually going to just go ahead and save these into a folder really quickly, show y'all what this can look like in terms of creating what we call a comparison. So here's some products. I want to look at them side by side. I'm just going to hit that button there, and this will generate a comparison. It'll allow you to see these products next to each other. Maybe a little slow today, but we'll jump in here and talk about what's coming next instead. So this is what a comparison will look like. Your whole team can leave comments. You can upload photos. It will have BIM CAD specs. If they're available publicly on the web, you'll be able to see them and download them here. Additional high-level information. What are the sizes? What are the finishes? It'll vary depending on what you're looking at. And then we'll also have these different performance graphs with different information for you. This all exists currently in the platform itself. Very, very handy. What's coming out is the ability for y'all to generate schedules as well from this. So everything you have in comparisons will then preload into this. This is something you can export as a CSV. What you can also do is say, hey, I really loved these 3 products. They performed well. I'm going to select them here, and I'm going to import them into my next project. The idea here with Acelab is that you're not only finding new products, but you're also able to document them and also take that information and knowledge to your next project, making things easier for you. All of this will also preload into what we're calling the spec planner, which will serve as an amazing kind of to-do list for you. That'll go over all the different items here. So if I'm scrolling down and I see, oh, we still don't have membrane roofing. Hey team, what are we going to use for that? So all this is what's coming. I'd love to meet with y'all, talk a little bit more about what this looks like, also ways to collaborate and set this up in terms of your firm structure to make this work for you. And so all that being said, I'll put my meeting link here. You can book with me. If you have any questions, let me know. And I will pass it back to Bo and Brock.
Thank you, Helen.
Yeah,
Yeah, feel free to respond yes to the poll we have up if you're interested in meeting with Helen to learn a little bit more about using Acelab. We'll reach out to schedule a time, and also keep your eyes peeled for the chat. Helen will throw her meeting link in there so you can just book a time directly. A few quick housekeeping items from me. We did collect AIA numbers upon registration. We will also send over a form in the chat momentarily where you can send us your AIA number in case you're worried you didn't include it. You can also request a certificate through that form. Certificates will be sent over email, and AIA credits will be reported directly to AIA by the STO team. So that's how that process works. If you've got any questions, we'll also share the link to connect with STO on Acelab so that you can jump over there and talk with that team. All right, other than that, just want to encourage folks to please submit questions to the Q&A throughout today's presentation. We keep an eye on those and have some time to get to some live questions at the end of today's webinar. And if we don't get to your question, we'll have a record of it so we can follow up with you after today's event. All right, that's it for me. Brock, whenever you're ready, feel free to share your screen and get started.
Awesome. Thanks for the introduction and the review, Helen. That was very, very helpful.
Okay, looks great.
So hello, everyone. My name's Brock. I serve as a Rainscreen specialist at STO Corp. We're headquartered in Atlanta, Georgia, but I'm based in Richmond, Virginia, and cover the mid-Atlantic states and most of the East Coast. Today's course is titled Building Codes and the Rainscreen Enclosure. We'll be exploring how to increased performance requirements impact the building envelope, particularly with Rainscreen systems. Before we jump into the content, we have a few housekeeping items to summarize. The presentation is copyrighted and should not be reused without permission from STO Corp. What is discussed today are the opinions and the views of the presenter and do not reflect the views or positions of AIA or any of its members in any way. Questions related to STO Corp specific content can be discussed after the presentation is complete. So let's get into it. Here we go. Here are our learning objectives. In this presentation, we will define Rainscreen and provide an overview of building control layers and Rainscreen system layers. We'll provide an in-depth look at steadily increasing building code performance, requirements, standards, and testing. We'll examine where building codes and testing standards intersect with the Rainscreen system, and we'll review the specific process and how best to prepare for future building code changes. In this first learning objective, we're going to provide a comprehensive overview of Rainscreen systems. This will include defining the term and functions of the system and reviewing the various control and system layers that make up a Rainscreen. While Rainscreen systems are considered newer in the US, Rainscreen has a long-standing history in other markets. In Europe, for example, the concept of Rainscreen kind of dates back to the early 1900s. As component manufacturers made their way into North America market, there was some confusion around what a Rainscreen was. In early 2020, an organization was formed in an effort to provide clarity and become the authority on Rainscreens. This organization is called RAINA, or the Rainscreen Association in North America. Now, RAINA has defined rain screens as kind of a double layer construction that utilizes a surface to help keep the rain out and an inner layer to offer thermal insulation, prevent excessive air leakage, and carry wind loading, and cavity between the two that provides drainage and drying. The term rain screen has been defined previously as a single building skin material, which is really just a cladding, or two, a collection of individual components aimed at functioning as a system, which we refer to as kind of a Frankenstein system, and we'll discuss the ramifications of these later on in the presentation. And finally, a building science principle, which is really truly what a rain screen is. In addition to the term and definition of a rain screen, there are actually a few different types. First, you have the drained and back ventilated rain screens. These systems rely on unrestricted air movement to drain and dry the wall cavity. Second, there are pressure equalized rain screens, which use multiple drainage compartments and air dams to achieve their functionality. These are more common on tall buildings, which are subjected to higher wind loading. And now, as rain screens become more popular in today's buildings, we as designers, specifiers, contractors, and installers should become more familiar with the functionalities of a rain screen. If you're not familiar with them, the function of a rain screen follows a 3D approach to rainwater management. To 1, deflect, 2, to drain, and 3, to dry. There are also other important building science requirements which extend this functionality to water management, which is a function of our ventilation cavity. Without the cavity, we no longer have a rain screen system. 2, structural integrity, which is determined by the cladding durability and impact resistance, as well as the subconstruction pattern and fastening schedule. 3, energy conservation, which is achievable with continuous outbound insulation and a thermally broken, thermally efficient subconstruction system. And finally, fire mitigation, which is reliant on full assembly flame spread tests and appropriate fire break details. We'll get into greater detail on these a little bit later in the presentation. So why specify a rain screen? Well, today rain screens are becoming an industry standard with incredible visual impact. Beyond that, let me give you some other reasons why you should consider a rain screen. On top of the practical benefits it brings, rain screen claddings and facades are also huge for aesthetic purposes. There are nearly infinite cladding options and subconstruction options that can allow even more creativity with the profile of the building. Because of the constant ventilation, they help greatly with harmful condensation and humidity, which can impact indoor air quality and compromise the wall over time. If you include high-performance insulation, they can provide improved energy and thermal efficiency to the building. Depending on the air gap in the rain screen, they can provide continuous air circulation and drying. And they can even extend the life of the facade and reduce maintenance costs over time, and even by protecting the control layers from UV. Finally, some rain screen panels come in really large formats, which can be panelized. Prefabrication and panelization means we can improve on constructability and the timeline in our job site. Now that we have a better understanding of the rain screen concept, let's move on to control and system layers. This is where materiality meets the environment head on. The 5 control layers of the building envelope are vapor retarder, air barrier, water penetration barrier, thermal barrier, and durability and water shedding layer. With a Rainscreen, these control layers are interspersed with the system layers that are unique to this type of assembly. We'll start at the face of our substrate and work our way back step by step to the finish. Let's break down the first control layer a bit. They consist of air, vapor, and water layers. They're most often installed directly on the substrate and inbound of the thermal barrier. They are often not three separate materials, rather this one product that performs multiple functions. Here, for example, we see a fluid-applied air and water resistive barrier applied directly to the face of the sheathing. This one material provides air, vapor, and water control. In a Rainscreen assembly, our dew point is in our cavity, which is in the outer third of the insulation and behind the cladding. Because of this, we want to allow an interior vapor to naturally permeate through to that cavity rather than trapping it somewhere within the wall. This is the value of the Rainscreen, allowing for constant drying and preventing water from getting into our buildings or settling somewhere within the wall assembly. Just note, some northern climate zones do advocate the use of vapor impermeable air barriers for their climate zones. System 2 of the exterior wall is the substructure, sometimes referred to as furring, subconstruction, or cladding support. It goes by many names. The function of these components is to literally secure the facade to the exterior building wall, as well as to create additional space between the substrate and the cladding to house our continuous outbound insulation and the ventilation cavity. Substructure can take the form of brackets, rails, hangers, clips, etc. They're typically made of aluminum, stainless steel, coated steel, and fiberglass. Lately, we've seen a new higher performance material enter the space called ZAM, which is a zinc aluminum magnesium coated alloy steel. Something else to note is most, but not all, substructure systems offer adjustability for walls that are out of plumb. Certainly, this is very helpful when retrofitting an older building where wall plumbness can vary to a surprising degree. Finally, substructure can be a significant determining factor in cost. For example, if you're hanging a very heavy cladding in a high wind load zone, you may need more hardware from one subconstruction manufacturer than you would from a different manufacturer. The amount and type of substructure pieces can also affect the thermal performance, just due to the number of pieces going through the wall. Then in system layer 3 of the exterior cavity is the insulation, which provides us our thermal control. This outbound insulation acts like a jacket for the building. This means we don't expend as much energy maintaining thermal comfort inside when it's particularly hot or cold outside. It's worth noting that insulation isn't always used in a Rainscreen system, though when it is, the most common and non-combustible would be to use mineral wool. Special attention should be paid to the type of outbound insulation used in a Rainscreen assembly because of the adjacent air gap. On to the fourth layer. This is your air ventilation cavity, which also functions as your drainage plane. As we discussed before, the ventilation cavity, system layer 4, allows water to freely drain in an unobstructed path down and out of the cavity. Although no standard ventilation cavity thickness exists, a cavity of 20 to 50 millimeters is often recommended, which is about 7/8 of an inch to 2 inches. However, some building science professionals do allow for smaller cavities. In fact, in Canada, they have a minimum of 10 millimeters, which is just 3/8 of an inch as their requirement. Because the ventilation cavity is so important with rain screens, I do want to emphasize its functionality, which is to promote drying of residual moisture, which is the key to the long-term performance of any exterior wall assembly. Without the ventilation cavity, the rain screen principle of enabling convective movement and exchange of air between the outer layer and the inner layer to dry the system would not be achieved. Moving to system layer 5, the facade panel. When you look at a building, you see its skin or the facade. Yet the facade is much more than an aesthetic. It acts as the first barrier of bulk water intrusion for the rain screen, and then allows the air and water barrier to really finish the job. Not only is the facade or cladding an aesthetic, but it is the first line of defense in the overall building. For our second learning objective, we'll be taking an in-depth look at the building code. We'll cover standards and testing that relate to those codes and how performance requirements are increasing for the building enclosure. Some key topics we'll be covering include the fire code, energy code, sustainability, impact resistance, wind load resistance, and overall structural stability. So the National Fire Protection Association, or NFPA, is the leading information and knowledge resource on fire, electrical, and related hazards. The ULC, or UL Solutions of Canada, on the right, has a similar set of standards and testing for the for the Canadian market. As you can imagine, from a health and safety and welfare perspective, their multi-story fire tests are among the most life-saving critical tests for a building enclosure. It not only benefits building occupants, but also first responders to a building in time of a fire event. Something to note, both the NFPA 285 and the S134 are system tests, plain and simple. They do not test individual components for combustibility. As you see in each image, the assembly is configured as a 20-foot high wall, which burns for a specified time, followed by an observation period. It's designed to examine behavior of the system or tested assembly and floor-to-floor fire propagation. Now, favorable NFPA 285 or S134 tests will allow the use of combustible materials where non-combustibility is specified. While non-combustible insulation is specified in a rain screen assembly, there may be additional components within that are combustible. This is why the assembly test is so important. For something as critical as health, safety, and welfare as the fire code, it's no surprise that local municipal codes would continue to increase their requirements. New York City has a very high population density, as do other large cities in the US, with neighboring buildings that are very close to each other. As such, changes are being made to the New York City building code with regard to fire blocking. As of late 2022, all buildings under construction that are taller than 70 feet will require fire blocking around all openings, horizontally at floor lines every 20 feet, and vertically between the occupancy units. These requirements continue to evolve, and acceptable fire blocking details are currently under development across the country. In this wall section to the right, you'll see one example of fire blocking in a rain screen assembly. This detail uses an intumescent strip applied to the face of the lamella block. For reference, lamella is a piece of particularly dense mineral wool. It's a type of mineral wool. And the intumescent strip is a special tape that, when exposed to extremely high temperatures, will expand and dam up the ventilation cavity, thus choking off any oxygen feeding the fire. It's a very important test. Local energy codes are increasing regularly. As we aim to significantly reduce the environmental impact in our cities. In New York, this is such a high priority that there are now policies that allow a building to come in contact with the neighboring lot line to allow for thicker, continuous outbound insulation. Thickness of that insulation may also be determined by the type of insulation used, the R value per inch, the amount of insulation in the interior wall, and the type of framing used. The current energy code in New York also requires calculating all thermal bridging, practice which is being adopted by many architects across the country. A thermal bridge is a place where in the wall where thermal conductivity can take place from the exterior to the interior and vice versa. Architects are also striving to exceed their local energy codes and achieve an even greater standard, like, say, net zero or passive house. A single source Rainscreen manufacturer can partner with an architect to help reach these goals. So in addition to the energy efficiency, sustainability is top of mind as we work to lessen our impact on our environment. Here are a few examples of industry standards that represent sustainability goals. An environmental product declaration, or EPD, looks at an individual product from a company from a raw material procurement through to finishing and shipping. It then provides a transparent report on how that product could potentially impact the environment. Now, B Corp takes the concept of EPD a step further. The certification process looks at the entire company, not just its individual products. This includes looking at ethical standards like hiring processes and pay scale, in addition to environmental impacts. Finally, local building codes are adopting policies that look at carbon emissions and their long-term impact. In New York, a policy called Local Law 97 is taking effect that will require the entire city to gradually retrofit. Increasing a building's performance also increases its lifespan, which reduces waste. Now, impact resistance is another important factor to consider when looking at health, safety, and welfare. There are a few different types of impact tests out there. First, the hard body impact test ensures that the panel will not collapse or deteriorate in a way that endangers bystanders or occupants. Shown here in the image on the left is an EN 356, which is a European standard for intruder resistance, is what it's called. So for this test, a 4-inch, 9-pound steel ball is dropped from a set height repeatedly onto the face of an opaque glass Rainscreen panel. You can see that the glass is broken into very small pieces, which is evidence that it's toughened or tempered. But it has also remained intact on the carrier board because of the high bond strength of the structural adhesive. Now, on the right, we see a soft body pendulum being prepared for the soft body impact test. So in this case, it's called, the test is called an EN 12600, which is another European standard for safety glazing testing. This test is intended to simulate the effects of human body contact or impact on a glass wall with the goal of reducing the likelihood of cutting or piercing injuries. There are also impact tests for the overall structural stability of the wall. One of the most reputable tests in the US is the Miami-Dade NOA. Part of their hurricane testing, this test simulates a large projectile striking the building in the event of a catastrophic hurricane. A 2x4 is shot out of a high-pressure cannon shown on the left from a set distance. The point and depth of impact is then measured and reported. The ISO 16933 shown on the right is a bomb blast test. For this test, different quantities of explosive material are staged at varying distances from the wall and then detonated. Pass-fail criteria for this test is that the Rainscreen system should not add to the hazard of human life safety that is initially created by the blast pressure effect of the explosion. This test is sought out for high-traffic public spaces such as airports, subways, hospitals, and museums. ASTM is an international standard organization that develops and publishes technical standards. A very important standard for your Rainscreen and exterior cladding is generally the ASTM E330. This test method determines the structural performance of your Rainscreen or cladding and is intended to represent the effects of wind loading on the exterior building surface elements. The result will give your cladding a design pressure, which, as I mentioned before, will determine your fastening schedule or the subconstruction furring layout. The image to the right is an example of an E330 test assembly. The edges of the test specimen are sealed, and then wind loading is simulated in both directions to try to push the panels into the building as well as pry them off. Ideal failure point will be somewhere over 200 miles per hour. Now that we've gone over some general building enclosure testing and standards, we're going to get a bit more granular in this section. Let's take a look at the specific interactions between Rainscreen systems and the building code. We've mentioned thermal bridging in previous slides. This photo is an example of a home without continuous outbound insulation, relying solely on bad insulation between the studs. Here you can see the outline of every stud and opening using a thermal camera. In a structure like this, the heating and cooling systems will have to consume much more energy to maintain thermal comfort on the interior side. In addition, our dew point ends up somewhere within that assembly, where the cold and warm air meet, producing condensation in the wall, which is not exactly where you want it. With a Rainscreen system, we often incorporate outbound insulation to help mitigate thermal bridging, like what we saw on the previous slide. That insulation rides over the studs, creating a jacket around the building. But what about where the subconstruction components fasten through? Here's an example of a thermal break using a thermal blocking element. This way, the bracket is not creating a sizable connection between the exterior and the interior. This significantly reduces thermal transmission. Something else to consider is strength and layout of the subconstruction versus the weight of the cladding. The more subconstruction you need to carry the load and affix the cladding, the more opportunities for thermal bridging there are. Something like this bracket, which has a small footprint on the building's exterior sheathing, is going to be far more energy efficient than, say, a continuous girt fastened down the wall and penetrating through to the exterior. In addition to things like thermal blocking elements, there are other ways to increase energy efficiency with Rainscreen systems. For example, aluminum is more conductive than stainless steel. As you can see from the chart here, an R16 can be achieved with just 4 inches of outbound insulation when using stainless steel brackets. With aluminum, you would need 5 inches of insulation to achieve an R16 CI value. The strength of the metal is also important, as we mentioned on the previous slide. The less metal we need to use to secure the cladding to the wall, the less opportunity for thermal transmission to occur. Earlier, we mentioned ZAM, which is an acronym for zinc, aluminum, magnesium, alloy coated steel. Aluminum brackets have a heat transfer rating of 201 watts per meter Kelvin, while ZAM coated steel brackets have a rating of only 45 to 50 watts per meter Kelvin, meaning there's a significantly less thermal transfer. Watts per meter Kelvin is how we would measure conductivity for a given material. ZAM galvanized steel has corrosion rate 3 times lower versus standard zinc galvanized metal. And ZAM also offers better protection against scratching due to a self-healing effect of the chemistry. You're going to see more of that technology in the marketplace. Because of the air gap, a Rainscreen system should only use non-combustible insulation. This reduces the risk of rapid flame spread up the cavity in the event of a fire. Now, that said, the system should still have full assembly fire testing. We mentioned this when discussing the multi-story fire test. This is particularly risky when specifying multiple manufacturers together in the envelope. This can lead to untested assemblies, and while the insulation may be non-combustible, like mineral wool, there could be another component that may be classified combustible. For example, a coating on a fastener or a type of cladding. If deviating from a full assembly fire-tested assembly, example, you're substituting an air and water barrier that was originally tested, you need to have a qualified fire engineer make the determination and issue an engineering judgment to make sure you're covered. It's very important. So this is an excellent example of a fire break detail in a Rainscreen system. Some architects and designers may be concerned that fire breaks, while necessary, will disrupt the overall aesthetic of the building. Here we see an intumescent strip over mineral wool safing held in place by a metal fire break. The metal is concealed behind the opaque glass, Rainscreen panels. This way, the building is high performance and safe while still maintaining the design elements. There are so many different options for claddings. It's important to note that while there may be many materials that achieve a certain look, not all will perform the same way. Brick is an excellent example of this. There are brick look tiles, thin bricks, resin cast brick slips, and of course, real full brick. All may be able to achieve the same aesthetic. However, they're all installed in very different ways. On the left, we see a carbon life cycle analysis of various cladding materials. Brick is far and away the least sustainable cladding material. It takes a tremendous amount of energy to power the kilns needed to fire brick. Once manufactured, brick is heavy and takes up a significant amount of space on a truck. This means you need more trucks and manpower to transport and install the same amount of square footage as another building material. Now on the right, we have a thin brick veneer over bonding and pointing mortar made to look like a full mortar joint. They're lighter, faster, easier to install, and consume less energy to produce per square foot than a full brick. The same look, same texture, but one option has a greater impact on our environment. Now, opaque glass is a very eco-friendly option for cladding, especially when compared to the alternative window wall or curtain wall. Glass has a unique aesthetic, one that's become very popular on high-rise projects. It's also naturally a high sustainable material. The main ingredient in producing the glass is, well, sand. You can also include recycled glass in the production process. However, you can't conceal continuous insulation between two panes of windows, like in a window wall, and glazed surfaces are generally not very thermally efficient. There are different treatments that can be applied to glass curtain wall to increase energy efficiency, but it will still have a lower R value relative to other wall assembly types. Now, opaque glass means that we can retain all of the positive green-friendly qualities of glass as a cladding and apply them in a way that allows us to build a more energy-efficient wall. We can also get even more creative with back painting, back printing, and specialty finishes and other aesthetic options unavailable to us with like vision glass. The number one way a building enclosure fails is prolonged moisture infiltration. This can corrode wall ties, freeze thaw can cause masonry to crack, standing moisture promotes mold and mildew growth. Rainscreens deal with the moisture management in the wall head on, which means these type of assemblies will generally last longer than others. This means reduced material over the lifespan of the building and reduced construction waste going into landfills. For our fourth and final learning objective, we're going to look at the best practices when it comes to specifying a Rainscreen system, especially in light of the ever-changing building code and testing requirements. To do this, I'd like to use the simple definitions of complete and incomplete associated with the term system or component. You'll also notice these symbols associated with the term system or component. So let's start with the component approach. In something as life-critical as a building, we should all be cautious of the by others mentality, which can lead to finger pointing and cause a lot of headaches. So with so much information burdening our designers, contractors, and installers in the form of countless drawings, details, product data sheets, warranty information, shop drawings, coordination, submittal packages, the list goes on. Certainly there can be natural confusion on how separate components should work together. Let's look at a few by others examples of the component approach to illustrate this incompatibility. So in this example, you have a detail from a substructure component manufacturer. They've called out a few components shown in green, which relate directly to the subconstruction and their product. Again, note here in red the number of per architect, per panel manufacturer, and per others callouts. In this example, it's a detail from another facade panel manufacturer, and we see, frankly, more of the same. The sheathing, air moisture barrier, and subconstruction are only generically defined or not even defined at all. Again, how you attach this product to the wall is up to you. If you look at this detail closer, shown is how you install the product horizontally. But what happens if it's vertical? Does that change any of the answers? Do I need a different substructure? Are there constraints with the insulation? Are there any constraints with the insulation? There's really a lot more questions than answers provided in this detail. Now let's shift from the by others details to a few real-world lessons learned about component incompatibility. Here's an image courtesy of Morrison Hirschfield, where they identified an unsightly misalignment of metal panels, as shown by the red arrows. They identified the root cause was due to incompatibility and improper use of the substructure or furring, leading to this eyesore in the facade. This is where the finger pointing begins, with someone stating, "This is not a problem with our product. Check with the other guy." In these photos, Morrison Hirschfield was contacted to investigate a stone facade which had fallen from the parapet. You'll see a photo. You'll see on the left where the facade had fallen from, and then on the right where it landed. Thank goodness nobody was hurt. This time, they identified the root cause was due to the incompatibility and the improper transition and detailing between the facade cladding and the substructure, therefore causing stress on the facade and the cladding. Again, the finger pointing begins with the various parties stating, "My detail's clear. It really must be the other guy." So let's shift gears away from the component approach to a complete systems approach to Rainscreen design. In this example, we see a holistic and systems approach to Rainscreen design, where all the components of this glass panel assembly Rainscreen system function together. All the components, meaning the air and water resistive barrier, the supporting substructure, the insulation, the facade, are all from a single supplier, all of which are complete, tested, and warranted. Even the fasteners have been called out, which can often be overlooked, as we saw before. Then moving to project example photos. As you can see in the photo on the left, we have a large project with some design complexities and coordination that will be needed. By sourcing a complete system, this makes the design complexity and coordination much simpler. For example, that manufacturer can review the product specified details to ensure that the system is buildable and functional. Again, in this example, we see all the components called out in the exterior cavity, including the attachment of the textured finish. While the details might look the same, manufacturers that offer multiple looks or products might have different requirements for attachment, which I mentioned previously. So it's always good to look to reference their details for the specific systems that you're looking for. Again, back to some project-specific examples. On the photo on the left, you can see that the subs can install the various layers of the exterior cavity all at once. Since the details are more clear, the sub can understand where the studs are located, where the transitions should occur, and most importantly, what's left, what's behind the previous layer, well, since they installed it. As we've discussed today, we're challenged by many factors in the construction process. Components not working together, creating collisions, the by others game, the amount of effort it can take to create a code compliant system. So how do we get to a complete Rainscreen? Let's start out with the why we need to get to a complete Rainscreen. Well, too often in today's construction, there's considerable value engineering and cost control, leading to piecing together of components. While this works and can lead to code compliant assemblies, we need to think about our exterior cavity as one whole assembly. By connecting design to construction, we know that design collisions will be reduced. We also know that by making things less complicated in the form of reducing the number of components to buy and the number of people involved on the job site, aka subs, the project will benefit. So in short, less product plus less subcontractors equals less collision. And all of this will lead to improved constructability and better project delivery. So why is this important? Think about a project you're on now or have worked on in the past. How many components or component layers were in the exterior assembly? How many manufacturers were involved? How many documents did you have to search for? Let's look at this from a simple math equation. If we take all the information we need for a project and sum it together, we get our Rainscreen assembly. In this Rainscreen assembly, we have all the control layers, the component layers, and the ventilation cavity. Then, thinking back to what we talked about earlier, these control and component layers have various components and each have supporting information. That supporting information can come in many forms, such as specs, product documentation, details, submittals, test reports, code approvals, and so on. As you start adding all of this together, you can see that it can become overwhelming, which I'm sure some of you already know. So by combining the equation from the two previous slides, we find that a complete Rainscreen system would become the sum of 1, all the components or materials, and 2, all of the supporting documentation and services required to understand, design, and install a Rainscreen. Let's play this out in a little but more of a real world scenario. So on the left, we have a single aesthetic facade. On the right, we have a combination facade. In scenario 1, looking at this from a component approach, in the single facade scenario, we would have roughly 4 components and 4 manufacturers. We also see a level of uncertainty around component compatibility and if the components are indeed tested as assemblies. Plus, we know that with 4 components and 4 manufacturers, we will have a lot of documentation and certainly a significant amount of coordination. In the second scenario, where we have a building with 2 different facades, or more, if you like, many buildings have more, we could perhaps double everything, say up to 8 components and 8 manufacturers. So the complexity goes up exponentially to oversee all these trades and make sure all the critical items are being addressed, especially where they interface, to ensure continuity across the control layers, like we talked about earlier. Certainly, we could get a bit more uneasy related to the level of uncertainty about testing and compatibility. Also, we know that the level of documentation and coordination will increase again, perhaps twofold. Regardless of the scenario we look at, Rainscreen design is also about managing or mitigating risk. As designers, contractors, and installers, we need to mitigate risk in all of our Rainscreen designs. By doing so, the building owner will benefit, as will those who live and work in the building. With the component approach, due to its complexity, risk is much harder to manage. What if there was a way, regardless of if you had a single aesthetic, dual aesthetic, or more, to have a complete approach? Intuitively, the level of complication would be greatly reduced. But by going beyond our intuition, we know that a complete approach will pay dividends from a design, tested, and warranted system, a single manufacturer, or at least reduced manufacturers, having certainty of component compatibility, having certainty of a tested assembly, requiring less documentation to research and collect, and by requiring less coordination with only one supplier or reduced suppliers. And with a complete approach, having less components, less manufacturers, less documentation, less design collisions, and by needing only a single system warranty from a single manufacturer, we will be able to reduce risk and give the confidence to our clients. Therefore, with a complete approach, we can deliver benefits and reduce complexity. By providing a full system warranty, compatibility of components, fully tested assemblies for fire, structural, and thermal to address health, safety, and welfare, weather-tight transitions, better design support to address the design collisions, provide an unlimited aesthetic options, and really just one phone call to make. Well, that was a lot. Thank you very much. Hopefully you have a better understanding of the various Rainscreen technologies, control layers, and component layers. And by specifying a complete Rainscreen that's tested as such, will increase the building performance and reduce the risk on your project team, the owner, and the occupants. This concludes my presentation. Thank you so much for your attention today. I've attached a QR code if you'd like to grab my contact information into your phone. That'll open up a V card and just give you a chance to save it to your phone. At this time, I'll be happy to answer any questions that you might have.
All right, awesome. Thank you so much, Brock, for a great presentation. Definitely a lot covered.
Thanks,
We do have
Bo.
questions, and if anybody has additional questions, now is a great time to throw those into the Q&A. All right, I'll just start off at the top. Why does the STO system locate the vapor barrier at the interior side of the insulation? Would that be different for different climates?
So the school of thought for the location and placement of that really is pretty consistent industry-wide. And your question was vapor barrier. Most of the time, we're going to use a permeable air barrier, air and moisture barrier, which is different than a vapor barrier. When I hear vapor barrier, I think of a zero perm material, or a 0.001, I think is a technical vapor barrier. And those are only used, based on my experience, in extreme northern climates, upper central Midwest and Canada and Alaska, places like that, to actually stop the vapor from going from one side to the other. Most of the rest of the country generally, and this is a general statement, prefers to see a vapor open air moisture barrier. But that's a really good question. And it's behind the insulation, you know, because the building envelope scientist like Joe Stiebrick says that makes the perfect wall, is to have it there. And it applies to roofs as well as to walls, as to the location of that material within the assembly. So a lot of people agree on the location.
So
That's a great question, though.
yeah, thank you to whoever submitted that question. All right, awesome. It looks like the rest are just thank yous in here. Oh, looks like we've got another question. We've got a few more minutes.
Okay.
All right. For metal cladding, choosing between aluminum or galvanized panels, is there any consideration for the Rainscreen support system accordingly for any galvanic reaction to use aluminum or stainless steel support systems?
So that there's always a consideration there, because when you mix dissimilar materials in a what I call the wet zone, right? That's you expect everything within the cavity to get wet. There is going to be a consideration. So depending on the composition of the metal panel, might make a decision on what you're using for the subconstruction. Sometimes stainless might be better. Sometimes the ZAM material, the galvanized, the zinc, aluminum, magnesium coated brackets do quite well. So yeah, that's always a concern with dissimilar materials.
Right. Awesome. All right, great. Well, it looks like everyone else in here is just saying thank you and that it was a great presentation. So I want to thank everyone in the audience so much for coming out today and for your engagement and for all of your nice comments in the Q&A. We appreciate it. And thank you, Brock, for such a great presentation. A quick mention that there will be a post-event survey as you're leaving today's webinar. If you have a moment to fill that out, super helpful for us to be able to keep bringing you content that is relevant to your practice areas. So please take a moment to fill that out as you're leaving today's webinar. There's also a few helpful links in the chat, so grab any of those that you might need. Got Helen's meeting link, the link to the STO page on Acelab. So feel free to grab anything from the chat that you might need before you head off for the day. All right.
Great.
With that, I think we should be all set for today. Thank you so much, Brock. We appreciate your time, and I hope everyone has a great rest of their Wednesday.
Thanks, everyone. Thanks, Bo.